Okay, hello everyone and welcome to this video. So this week on week 12, we have covered the distribution of sampling statistics as well as parameter estimation. So although we covered the main idea of what we're trying to estimate or infer in these two chapters, we haven't had the chance to go over each case individually and in detail. So to help you out, I will be releasing, as I mentioned in class, an exercise for you to do independently and individually this week, and the deadline will be next week. But to help you out, to start off, I will release this video as well together with the exercise in which we will go over some sample exercises that should help you with your completing of the exercise individually. So without further ado, I'm going to go directly to the sample exercises that I have prepared. Okay, so these are the sample exercises. Let's start with number one. A market research analyst for a telecommunication company has conducted a study on consumers that are late with their monthly payments. They found that the time of delay, the late payments, follow a normal distribution with a mean and standard deviation of 44 hours. So both the mean and standard deviation is 44 hours. And then the analyst took a random sample of 60 customers that had late payments. So in this problem, you are asked to compute two things, A and B, and it does not yet actually have to do much with the distribution of sampling statistics or parameter estimation that we covered this week, but it gives you a good idea where it comes from, because we're already trying to analyze the normal random variables and how they behave when they are combined. So let's look at number A. So here we have the information of X. That's the amount of time until the late payment. And we know that this follows a normal distribution of 44 mean and a variance of 44 squared. So for number A, what is being asked of you is, what is the probability that any random customer has a late payment of at least 40 hours? Okay. So here we have X, and we want to change it to obviously Z. Recall that standard score Z can be computed by taking X, subtracting mu, and dividing by the standard deviation. So to do that, we just simply do that for the X part, and we do 40 minus 44 over 44. This is the mu, and this is also the standard deviation, which gives us PZ larger than negative 4 over 44. Let's compute that real quick. That's Z over around negative 0.09. So obviously, we know that when we're dealing with standard normal variables, we cannot compute a larger than, but we can compute the less than. So let's change that into less than for a visualization. I'll draw this here. This is our standard normal distribution. And what I want to compute is, this is maybe negative 0.09. What I want to compute is Z being larger. So this area under the curve, larger than on the right-hand side. But since I can't do that, I can just compute, on the other hand, 1 minus the left-hand area. Or in other words, 1 minus PZ less than negative 0.09. And here it is around, this is the phi, sorry, of minus 0.09. So if we look at the table, we can look this up real quick. Minus 0.09. So minus 0.09 would be this end here. So 0.464. Or in other words, this will be, where am I? 1 minus 0.464, which is somewhere around 0.536. Okay, so that's for the first question, A. Now let's move on to question B. So on the question B, what is asked of you is no longer the probability of one customer's delay, but the average delay of 60 customers, or the average delay of 60 x's, 60 random variables. So if you recall, when we studied the combinations of various random variables right here, we already looked at what happens when you average some independent normal random variables. If each individual random variable follows a normal distribution, then the average of them will then follow this new distribution here. So if we put our values into this one, we now know that our average for, and this is the amount of points we have 60 here. So we can translate this, and we now know that our average will follow a normal distribution with mu does not change, so it's still 44. And however, the variance of this distribution is 44 squared divided by 60. So in our new distribution of X bar, this is our mu, and this entire thing is our variance. So when they ask us to compute what's the probability that the average delay time of 60 customers is more than 40 hours, what is being asked of us is what is the probability that X bar is more than 40 hours. Once again, what we need to do first is change this into a standard normal variable. So what I'm going to do first is minus mu and my standard deviation, and larger than 40 minus 44, that's my new mu. But my standard deviation now is the square root of that entire thing. So if I square root 44 squared 60, the top part is still 44, but the bottom part is that. So in other words, I need to divide it with this new standard deviation. And thus I will obtain PZ being more than -4 over this equation here. So I've already pre-computed that, and it falls somewhere around -0.70. And once again, larger than cannot be computed, but I can compute 1 minus PZ less than -0.70, or in other words, 1 minus phi of -0.70, which is, if I look up the table, is around 0.75. Okay, so that's the first problem. We have already reviewed the normal random variables and what happens when we try to combine them. So now I'm going to go on to number 2. Okay, so for number 2, let's read it together. An operational manager wants to know the average time needed by factory workers to put together a component. We know that the standard deviation of time needed by the population is 4.8 minutes. After observing a sample of 140 workers, they found that the average time of those 140 workers is 18.4 minutes. And thus we want to now determine the 92% confidence interval for average time needed overall to put together the component. So let's look at what we do know here. we know that the standard deviation of the population, so here I can already write, this is the standard deviation of the population, is 4.8. In other words, the variance is 4.8 squared. And here I have a sample of 140 workers. So this is my N. And the needed average time for those 140, so this is the sample mean, is 18.4 minutes. So we now know that we have a population with a known variance, and I have taken a sample from them. So here, let's look at the parameter estimation slide. So among all of the information that we do know, among all of the information that we do know, this falls into, let's look at what category it falls in. So here we know that this sample comes from one population. So the one population is those workers. And I want to construct the confidence interval of a mean, of the normal mean, which is the mean of the population. And from my information, I do know the variance. So this falls into this category. And if I look into the confidence interval for a normal mean when the variance is known, it will be this one. Sorry, we still have our annotations here. Let's delete that. So this is the confidence interval for a normal mean when the variance is indeed known. So I'm going to copy that equation to our problem. Okay, let's move that over here. Oops. Can't move that. Can I move that over there? Yeah, let's move that over here. Okay, anyhow, kind of big. I don't need it that large. Okay, so while I paused the video just now, I got this graphic together. So what we want to compute is a two-sided confidence interval. So this one part here, this one here, I want to compute the two-sided confidence interval. And I know that my confidence interval is 92%. So that means that my alpha, so since the confidence interval is 101 minus alpha percent. So if I'm talking about, oops, let's just write that down, sorry. 100, 1 minus alpha, 1 minus alpha percent. So if I'm talking about 92%, so my alpha will be 0.8. But, and thus when I put this in, I need to use alpha divided by 2 because of the two-tailed interval. So when we're talking about one tail, we only put the 0.8 on one side. But since we're talking about two tails, I need to put the 0.8 on both sides, 0.4 on this side and 0.4 on the other. Oops, sorry, 0.08. My bad, sorry guys. 0.04 and 0.04 on this side. Careful with this. You might also encounter this error when you're computing. Be careful with your precision. Okay, so based on this equation, I can then compute the two-sided CI directly. When I want to estimate the confidence interval for average time needed overall, so it's the average of the population. So I know now that the mu, or the population mean, should fall between these two limits, which is the sample mean, which is 18.4, minus z, what's my alpha? It's alpha divided by 2, not 0.08, Z04, and my this is the sigma, which is the population standard deviation. It is 4.8, sorry, divided by the square root of n, 140. And the other limit is 18.4 plus z 0.04, 48 over square root of 140. So this z, the z of 0.04, as you recall, it's the percentiles. And so it is the opposite of your lookup table. And in the case of these confidence intervals, you will usually be given the values to be used. So z 0.04 or z 0.05, whatever it is. For the commonly used alphas, you will be given the values of the z alphas. So here, we already know that from the table that z of 0.04 alpha is 1.73. So I'll put that in, 18.4 minus 175. And this is 48 and so forth. This other end is the same, it's only a plus. So I've already pre-computed this. You can just compute it on your own if you want. And this will be somewhere around 18.4 minus 0.71 and 18.4 plus 0.71, resulting in a range of 17.7 and 19.1. So from here, this conclusion tells us that when this operational manager wants to compute the average time needed in the population, then it should fall, the population mean should fall between 17.7 and 19.1. Okay, following this, we have a similar problem of constructing a confidence interval, but this time we have different values. So this is following the same procedure. We'll do the same. What we're going to do here first is to figure out what information we do know. So this is my sample. I know this is my M. And among them, so among the sample, we have an average typing speed of 60 words per minute. So this is my sample mean. And I know that there is a standard deviation of 6 words per minute. But be careful, this is the S. Okay. So this is the S because I know that this is the standard deviation of the 12 students. I do know that I can assume that this is following a normal distribution. However, among all of the cases that we do have, so once again, we'll go into the cases that we know. So in this case, we know that we have one normal population, which is Fasilkom students, but I do not know the variance of the population. I do know the variance of the sample, but I do not know the variance of the population. Thus, from that, we know that this will fall under this category. And let's go to find the equation for that particular case. So here is what happens when the variance is unknown. Obviously, what is the difference is that no longer can I use the Z table or the standard normal variable table, but I have to use the T table instead. Okay, so now I've copied the necessary equation back to our problems. And here we have the two-sided CI, which is necessary for A. And we also have the one-sided lower confidence CI for this one. So this is the one-sided lower CI. Okay, so we can just directly put that in. So for the question A, what we need to compute is, I want to compute the average typing speed of all Fossicom students, or in other words, the population. I know that it will fall into this range. So X bar is 60 minus T alpha divided by 2. So my alpha here, oh, sorry, we haven't talked about the alpha. So now what I need to compute is the alpha here. So 90 is this is my confidence interval. So if this is 1 minus alpha is 90. So thus my alpha will be 0.1. So here, when I'm talking about the alpha divided by 2, so this will be 0.05, which is a half of 0.1005. And my, for a t distribution, I need to know the n minus 1. So here I have 11. Here is the S, actually. This is not supposed to be written as sigma. Apologies, this should be S. So here I have the S of the sample, which is 6, divided by the square root of n, which is 12. And on the other end, I have 60 plus t 0.05 and 11, 6 over the square root of 12. Okay, so let me pull up the t table now. Okay, so here is our t table. And just now what we needed to look up was t 0.05 confidence and 11 of our n. So here our n is 11. So it's somewhere here. And our confidence of alpha is 0.05. So 1.796. So here we have 60 minus 1. Sorry, I already forgot it. 11 at 1.796 over these computations. This is 1.796 over 12. So you guys can continue this computation using your calculator, but I've already pre-computed it for you. This will be on this end, it's 56.89 and 63.11 for the upper limit. So obviously for B, what we need to compute is the one-sided one. Once again, this is not sigma, this should be S, apologies. So here I have to compute the mu, which should fall under the left-hand side is negative infinity, because I'm only going to limit the upper side because this is the lower CI. And here we know that I would like to compute the other side, which is 60. Let's just plug it in, plus T alpha. So now it's not alpha divided by 2, it's alpha. So it's 0.1 and 11 is our n minus 1. And this part is 6, still the same, 6 over the square root of 12. So to spare you some time, we've already looked up this t value. So it should be around 1.363. 1.363, 6 over square root of 12, which is around, the mu is between negative infinity and 62.36. So as you realize here that we have a range of possible values here. So the conclusion we can take from these two equations is that when I have both limits, this side, I have a range of possible values that could be the population mean. And this is the same. However, obviously this is a lot more stringent, the first one, because I have both limits. but this also gives me a larger margin of error because I could be wrong. However, for this one, I have a larger uh, range, and that means I have a bigger probability to be right. Okay, so that brings us to the end of the sample exercises. And at the end, together with this video, I will be releasing the exercises for you to complete on your own. I hope this video helped you to understand how to decipher these types of problems on your own, and good luck.